Mathland! It looks like I've been multiplied by a scaling factor larger than 1, less than 1. 15 thirds. Scaling factors have to be in what form? Fraction form. Awesome. Little bit of review. I'm so excited. This is a very funny angle. I have not grown. I'm still the same size, but I'm trying to block. We're recording live from the classroom. There's actual humans in here with me. It's very exciting. But I need to make sure that those humans aren't on video, and I'm blocking those humans with my large-scaled body. We're getting into lesson 23. Oh, Michael Jordan numbers. Yes. Oh, yeah, and LeBron. Michael Jordan's better run. What are we doing in lesson 23, guys? So we have very special mathematicians with us today as your guests. Do you want to say hello?
Hello.
What are we doing in lesson 23, guys?
We're comparing the size of the product to the size of the factors.
We're comparing the size of the product to the size of the factors. It seems like scaling factors are coming with us.
Yes.
Okay, beautiful. So this is really just a really nice accompaniment to lesson 22. We're going to continue considering what happens when you multiply a number by a scaling factor larger than 1, smaller than 1, or 1. Keep in mind, scaling factors have to be in what form?
Fraction.
Well, I guess we're seeing them in fraction form, and what other form in lesson 23? Decimal. Cool. So, you ready?
Yes.
Let's go. So before we have, before we get into the guest teachers, I'm going to check out some, just this problem with you. Number 3, it has 4 parts, and just kind of talk through this, and then you will see your guest teachers here momentarily. I'm going to choose that lovely color. Here we are asked to write a statement using one of the following phrases, in bold here, to compare the value of the expressions. Then explain how you know. Okay, so our options are is slightly more than, is a lot more than, is slightly less than, and is a lot less than. And we have 4 different expressions here, and instead of just the basic greater than, less than, equal to, no offense, these are great, these are great symbols, but we're just kind of taking it up a notch, and we're considering, is it a lot more than? Is it slightly more than? And so we're just kind of honing in on what we were doing in lesson 22 and just kind of going deeper into that. So here we're multiplying 4 by a scaling factor of 988 thousandths. 988 thousandths can also look like that in fraction form. 988 thousandths. Beautiful. So if I were to multiply, so 988 thousandths is less than 1, right? So this is less than 1, smaller than 1. If I were to multiply something that's smaller than 1 by 4, what's going to happen to 4? Well, it's just it's so close to 1. It's 988 over 1,000. So what's going to happen is this, because this is just slightly less than 1, the expression that we want to use will be here. When we multiply this by 4, the result is going to be just slightly less than 4, because 988 over 1,000 is just slightly less than 1. Okay, let's look here. Scaling factor, well, I'll drop scaling factor for a second, but using what we know about scaling factors, if we multiply something, here. So the scaling factor is a little bit more than 1. I know this is a scaling factor because this is our product here. So if we multiply 8 tenths, by something that's just a little bit bigger than 1, so 8 tenths is being multiplied by something that's a little bit bigger than 1. The result is not going to be a huge dramatic change, right? The result is going to be just, I'm going to be kind of lazy about this. The result is just going to be slightly more than, because we're multiplying 8 tenths by something that is just slightly more than 1. So our result is going to be slightly more than our original 8 tenths. Do you guys kind of see what's going on here? Cool. Let's check out this. So we have 1,725. that's the number, our base number, multiplied by 13 thousandths. That is a teeny, 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 tiny number. 13 thousandths is very small. It's much less than 1. It's really small. It's quite a bit. So if we wanted to look at 1 in terms of thousandths, that would be 1,000 thousandths. This is only 13 thousandths, so it's little. So we're multiplying 1,725 by something that is much, much, much less than 1. 13 over 1,000 is a lot less than 1. So our result is going to be a lot less than our original. Cool. Let's look at this one. Here, our base model, or our base number, is 1 3 thousandths. Okay, cool. We're multiplying 1 3 thousandths by 989 and 1,000th. Let's think about 989 and 1,000th. Is it equal to 1? Is it a lot less than 1? No. It's tons more than. So our result, when we multiply 1 3 thousandths, when we multiply that by 989 and 1,000ths, it's going to be a lot more than its original, because we're multiplying it by a lot more than 1. See how that's working out, you guys? So moving forward, this is what I need you to consider. When you're multiplying something that is 1, you know what happens. Nothing happens when you multiply something by 1. You're just making one copy of it. When you multiply something by a lot more than 1, like a number that's way larger than 1, the number grows significantly. Cool? When you multiply something, when you multiply a number by something that's a lot less than 1, that number is going to shrink significantly. Think about, and this is so important, think about Mrs. C at her normal size. Think about how you can increase Mrs. C, what you have to multiply me by, and then think about how you can decrease me. You can do all of this just multiplying me by different scaling factors. Cool? Okay, I'm going to hand this over to my guest teachers. Let's go.
Okay, so we're doing number 1. Fill in the blank. So we're up here. Fill in the blank using one of the following scaling factors below these, right here. Factors to make each number sentence true, okay? So right here we have 3.4 times blank equals 3.4. So we're going to try to make the same, no changes. So it would obviously be 1.00. That's 1.0 up. B, we have blank times 0.21 is making this one larger than this one. So we have to make this one larger. So that would mean we'd have to make it 1 point, because we have to make it 1.021, because 1.021 is basically 0.21 with adding a 1 to it, so it would make this larger. It would make this one a larger number. Okay, lastly we have C. C is 8.04 times blank makes this number larger. So now it's 8.04 times something makes this number larger than this number. So we're going to try to make this number smaller than this number. So that would make it this one, because 0.98 is less than 1, which makes this number smaller. Okay. Okay, so press the button.
Okay, I think that's it.
Okay, so gonna be doing number 2. All right, let's read it. Sort the following expressions by rewriting them in the table. So I'm not gonna exactly rewrite them. I'm just gonna like circle them and put an arrow like into the box that it's supposed to go in. So, all right. So let's do this one right here. 13.89 times 1.004. That would go in the greater because okay. Next one. Let's do this one now. 0.3 times 0.069 would go in the less than box. So go there. Okay, that was really bad. All right. And then 602 times 0.489 would go in the less than box. So drag that over there. That is such a bad arrow. And then let's do this one now. 0.72 times 1.24 would go in the more than box because this one is way bigger. So let's do that. And then this one, 102.03 times 4.015 would go in the more than box. Bigger than this one. And then 102 times, 0.2 times 0.1 would go in the less than box. So try this right over there. So, well, that's it for today, guys. Thank you. Oh my god, this took so long. Good job.
Thank you. Okay.
Thank you. Oh my god. In big letters.
Okay.
Ooh, yeah.
That is so bad.
Okay, bye.